Okay, so well, what I'm going to do is to show you some results on one of the points that were raised at the very beginning in the first talk from the person from the representative from Eurostat, no? In which he was talking about the validity of the data and how they were kind of reluctant to enter into the question of the big data to analyze mobility, population levels, activity, and so on. No? This was an issue that we also addressed in a European project some years ago. It actually was a FP7 about transport and mobility. And of course, when we started to work with big data, this was one of the first questions that we wondered. We are talking about how many people is moving from one place to another, but this is something that you can measure with any kind of data source, or you should be very, you should be kind of not so brave to enter into some kind of data sources, or you can use all of them and interchange them. No, in this case, this was a collaboration also with Telefónica that was providing the data from the mobile phone records. And then CSACLE and Nomon, which is a small research company based here in Madrid. This was kind of motivation slide just to show you the kind of things that you can do with this type of data. This was Twitter analysis that we did the last year about the attractivity of the global touristic sites, trying to do a ranking of which ones are the most attractive. In this case, it was mostly, attractive in the sense of attracting people with different origins. No? So essentially the most diverse, let's say, tourists that are coming to those places. But this was mostly motivation because I wanted to show you the possibilities of this kind of data. But we have already some very nice examples in the first talk, and in the talk after was from the representative of the Italian government. No? So let's go far, and let's go to the point of the comparison of the different data sources. As I was telling you, in here, what we wanted to make sure is that different data sources were going to provide the same kind of information. To do that, you had to define the geographical size. In this case, what we have here in the map is Barcelona. The analysis was done in Barcelona and Madrid because it's the places where we have most data. And what we did, this was to transform the city in this kind of grid of 1 kilometer by 1 kilometer cells. We also used half kilometer cells and 2 kilometers to make sure that everything that we were finding was reasonable. And what you have there is essentially the number of phone users that we are seeing in the city at one time, no? in a common week. And we had a month of data in this case for the mobile phone records. For Twitter, we have the same kind of data and the same period of time, but we have also more data because we were collecting this information for longer time. These are geolocated tweets. So for those that are not so familiar with Twitter, this means that some of the tweets, or you can activate in some of the tweets the possibility of the tweet to contain your geolocation, and this will give you a quite detailed information because this information is usually used on GPS or on network located GPS. No? So essentially, it's a kind of quite precise points. This is again in Barcelona, and you see every small green point is one of these geolocated tweets in the same period of time. The curves of activity, as you can see there, are slightly different from the mobile phone records, which means that actually they are representing, they are coming from the same thing, it's mobile phone systems, but people is tweeting more when they finish work. So essentially, let's say the second peak is higher in the case of Twitter than in the mobile phone case. No? And the final one is just surveys. This is the traditional way. Because as it was also said in the first talk, the traditional things in tourism, but also in transport and mobility, are doing surveys. And this is an example of the survey that was done every year in Barcelona. The question on the surveys is that you can control everything. You can control which is the sample. You can select the characteristics of every person that is going to participate in the survey to avoid biases. But on the other hand, it's very expensive because doing these surveys these were surveys, the DMF is usually around 3,000 people, cost several €100,000. Okay, so while the data from the mobile phone records or from the Twitter are, of course, they were intended for other things, let's say, but a priori for this kind of applications come with very low costs. So okay, we have the three data sets, and then which was the comparison that we wanted to do? Well, the first one was about activity. And well, I'm sorry, but I think that you are not seeing the plot well. There was a heat map on the right comparing the two activities in the city of Barcelona, cell by cell, no? And then what we're doing here on the left is to see the population of users that we are seeing in the different cells. Every point is a cell in this case, and we have the proportion of Twitter users on the x-axis and the proportion of the mobile phone users in the y-axis. In this case, I mean, as you can see, the correlation is quite high. We are talking about 0.96 for the correlation or even for R-squared. Eh? So essentially, you assume a linear relation. The two of them are in the same order of magnitude, so they are telling you that a priori in this scale, Twitter and mobile phone records are equivalent. Okay, so in the kind of information that they can provide. After that, I mean, we did also, let's say, separating weekdays from Fridays, Saturdays, and Sundays, because you can think that actually mobility is, and the activity can be very different from one day to another. And in all cases, also Madrid and Barcelona, we found correlations over 0.8. So essentially, as I was telling you, in this case, or at these scales, the mobile phone and the Twitter data are equivalent. The next one was about OD matrices. OD matrices means from cell to cell, let's calculate the flows of people that are moving from one place to another, okay? This gives us, in this case, every point is one of these origin destinations, let's say, and you calculate the flow based on Twitter and based on mobile phone records, and what you do is to compare one and the other. And as you can see here, I mean, this is log because I'm coming from physics, so essentially we like always this kind of big scales log things, but a priori in a linear, of course, they think it's much more attached to the diagonal. So essentially, you get also very high correlation. So essentially, what is this telling you is that at least at this scale, and remember, 1 by 1 cells, kilometer square cells, the two data sources are still equivalent. So still you can use Twitter at this scale to obtain mobility, as you can use mobile phones. And just the final thing, just to make sure that there was no trick, what happens with the service? Well, I mean, the service, we have to change the scale because the service comes at the sizes of census tract. So essentially that they are bigger than these cells that I was showing you. And then that means that we have to aggregate. So we aggregate the areas that we have in Twitter and in mobile phones. And when we do the comparison, these are down here. As you see, I mean, actually the correlations even improve because, of course, you aggregate, so the signal is even stronger, and the noise gets reduced. So essentially, in all these cases, what we are showing is that in the case of flows, this is flows of commuters, so the ODs that I was telling you, Twitter and census, mobile phone and census, and Twitter and mobile phone are providing you the same kind of information. So after this, we did some other work because this was in 2014, as you can see there. The publication was on this case. And last year, we were working also with mobile phone records, trying to specify how much you can reduce the geographical areas to still get a good signal. And this was published in this other paper. In these cases, I mean, what we can say on this is that yes, I mean, the different sources of data for activity and mobility are equivalent in these cases. Of course, there are some resolution limits. Like, for instance, if we are talking about smaller and smaller cells, you may have problems with the way that you are collecting the data from the mobile phones that are essentially areas of service of the towers. That means that essentially you cannot go below a certain size because otherwise you will not get the information about the position. And also you will have problems with Twitter if you go to very small areas because you will lose, let's say, the statistical power of the data. And well, that was it. Thank you very much for your attention.